Welcome back. We are now going to officially discuss lateral or imaginary numbers. A lateral number is a number that can be written in the form a plus bi, where a and b are real numbers, and b does not equal 0. Examples of this would be 5 plus 3i, or root 3 minus pi I. And lateral numbers appear in engineering and physical sciences, and really do exist on the complex axis, which we cannot see on our calculators. Do not let this name fool you. You can really use these. They are really there. They really do exist. Now, we're going to take this idea of imaginary or lateral numbers, and we're going to combine them either by addition or subtraction with real numbers. When we take the union of the set of all imaginary or lateral numbers and the set of all real numbers, we get the set of all complex numbers. Now, in previous videos, I've kind of used imaginary numbers and complex numbers interchangeably, but at this point we have to start making a very clear distinction between the two of them. When you have an I by itself, it's a lateral number. If you combine it with something else, like an actual number, and you add it or you subtract it from a real number, then you can get this idea of a complex number. You can think of it as lateral numbers are just one thing. Complex numbers are combined with either by addition or subtraction with another real number. So let's list a few. So here are some try-its, I guess. Try to decide if this is a complex number or lateral number. Okay, so I have 3 examples here. 2 plus root 3. This is almost a trick question. It does not have lateral numbers, and it is not combined with another number to make it complex. So this is neither. Now let's look at plus or minus I. Plus or minus I is a lateral number. Lateral because it doesn't have that additional real number combined with it. And then lastly, we have 7 plus or minus I root 3. This has both a real number, 7, and a lateral number combined together with either plus or minus in between. So this is a complex number. So for this example, we have addition and subtraction of complex numbers, and then multiplying complex numbers. Let's start with addition and subtraction. The commutative, associative, and distributive laws hold for complex numbers. We can add and subtract them as we do binomials. So let's try adding or subtracting example 2a. We have 8 plus 5i in grouping symbols, plus 4 minus 2i in grouping symbols. You can think of the 5i and the negative 2i as terms that are separate from the 8 and the 4. So 8 and 4 are like terms, and 5i and negative 2i are like terms. So if we combine them, we'll have 8 plus 4, which is 12, plus 5i minus 2i, which is 3i. In part B, we have 4 plus 5i minus 6 minus 3i. And so we have to subtract that whole second grouping. Let's just rewrite the whole thing. 4 plus 5i minus 6 plus 3i, distributing the negative. The terms with i's will combine, and the terms that are just real numbers, in this case integers, will combine. We have 4 minus 6, which is negative 2, and 5i plus 3i is 8i. Now let's look at multiplying complex numbers. To multiply square roots of negative real numbers, we first express them in terms of I. So in this exercise 3, we have quite a few examples. Perform the indicated operation and simplify. Write the answer in the form a plus bi. Now if you think you know how you're going to attack these, go right ahead. And just pause the video. I'll work them out here in just a second. Welcome back. Let's give the first one a try. We have the square root of negative 36 times the square root of negative 9. This will give me the square root of, this will give me I times 6 times I times 3. Now, if you're looking at that thinking that looks a little weird, I agree with you. It does. We're going to multiply these together. So I'm going to multiply the 6 and the 3 together, which gives me 18, and then I multiply that by I squared. Now remember, I squared is equal to negative 1, so we can rewrite this as 18 with a negative in front of it. This is what that product is equal to. Now let's look at 4i times 5i. This will give me 20i squared. And we know that I squared is equal to negative 1, so we have negative 20. In part C, we have negative 4i times the quantity grouped 3 plus 5i. I'm going to distribute that negative 4i to both terms inside parentheses. This gives me negative 12i minus 20i squared. Now we know that we can't really simplify the I. We're not going to replace it with a root of negative 1. We're just going to leave it like that. But this I squared we know is equivalent to negative 1, so we'll have negative 12i plus 20. Now in this next exercise we have 5 minus 6i times 2 plus 5i. These are binomial factors multiplied together, so their product will be found using FOIL. 5 times 2 is 10. 5 times 5 is 25. And that does have an I with it. The inner will be negative 6i times 2, so negative 12i. And negative 6i times positive 5i will be a negative 30i squared. Combining like terms, we'll have 10 plus 13i minus 30i squared. Now don't forget, the I squared is equal to negative 1, so we can rewrite this as 10 plus 30 plus 13i. And my final answer comes out to be 40 plus 13i. Now let's FOIL the next binomial. We have 3 times 3, which is 9, 3 times negative 4i, and 3 times positive 4i will add to 0. And lastly, we have negative 16i squared. Well, that will be 9 plus 16 when we remove the I squared and replace it with a negative 1. This gives me a final answer of 25. And then our last example is 4x plus 3i times 4x minus 3i. Notice that they're identical except for the sign on the second term in each binomial. That gives me 16x squared minus 9i squared. And remember, I squared is equal to -1, so we have 16x squared plus 9.